ask your computer for 0.1 plus 0.2. The honest answer is not 0.3. It's this. Here's why. Try writing 1/3 as a decimal, 0.333 forever. It never ends. In binary, 0.1 has exactly the same problem. So computers store real numbers like scientific notation, a sign, a fraction, and an exponent packed into 64 bits. That buys an enormous range, but only so many digits of precision. 0.1 gets rounded to the nearest fraction binary can hold. So does 0.2. Add them, and those two tiny errors peek out in the very last digit. That's why banks count in whole cents and programmers compare with close enough, not equals. It isn't broken. It's a trade, a little precision for enormous range. Infinite numbers, finite bits, something has to give.